Hi, this is Joshua. Today I'll do a short briefing for MIMO system. Before we discuss the MIMO, let's see what is MIMO. MIMO is the antenna technology for wireless communication in which multiple antennas are used at both the source and the destination. But how does MIMO improve the spectral efficiency? Let's take a simple example. In CISO system, there are only one transmitter and one receiver. So when we send message 1, Y will get message X as the receiver, and Y equal to HX, where H is the attenuation during this transmission. But in a simple MIMO system, let's say a 2x2 MIMO system, we have 2 transmitter and 2 receiver. Message Y will be separate into Y1 and Y2. Then the message, the transmitted message will be reduced, and each message will be transmitted by different antennas. So each receiver will receive two different messages, X1 and X2. We can see it's a simple. There are two simple equations. When we send in the real transmission. In the real transmission system, we will send a calibration signal. Then we can get H11, H12, H21, and H22. It's quite simple. Then we can see the transmission efficiency will be doubled. But currently, as the MIMO is good. And currently, the mainstream MIMO technology is multi-user MIMO. Although multi-user MIMO offers a big advantage over conventional point-to-point MIMO, but it is not a scalable technology. Means it cannot be upgraded. And with the explosive growth of wireless data service, especially more and more requirement for high-definition videos demands higher capacities of future wireless communication system to meet this trend. And one efficiency solution to this problem is to improve the spectral efficiency. How? Then we think, we can try to improve. We can try to improve the antennas, use more antennas. Yes, that is massive MIMO. For a large number, we can use a large number antennas, large number of service antennas. Massive MIMO make a clean break with current practice through the use of large excess of service antennas over active terminals and the time division duplex operation. Extra antennas help by focusing energy into every smaller region of space to bring huge improvements in throughput and radiate energy efficiency. From this table, this table is a comparison between the massive and the conventional MIMO technologies. We can find that the channel capacity, diversity gain, link reliability, noise competing capability of the massive MIMO are higher than the conventional MIMO, and the SER is lower than it. So that's we can say, massive MIMO has a huge potential because it's really good than the conventional MIMO. Just now we said massive MIMO has a huge potential. So let's discuss the potential. Massive MIMO can increase the capacity 10 times or more and simultaneously improve the radiate energy efficiency on the order of 100 times. The capacity increase results from the aggressive spatial multiplexing used in massive MIMO. The fundamental principle that makes the dramatic increase the energy efficiency possible is that with a large number of antennas, Energy can be focused with extreme sharpness into small region in space. The underlying physics is coherent superposition with waveform. By appropriately shaping the signals sent out by the antennas, the base station can make sure that all wavefronts collectively emitted by all antennas add up constructively at the location of intended terminals, but destructively almost everywhere else. Okay. Massive MIMO can be built with another potential is the second potential is massive MIMO can be built with expensive low power components. Yeah, we know that massive MIMO is a game-changing technology with regards to theory, system, and implementation. With the massive MIMO, expensive ultra-linear with the massive MIMO. Expensive ultra-linear 50 watts amplifier used in conventional system are replaced by hundreds of low-cost amplifier. Yeah, although you think it's hundred amplifiers, but for this 100 of amplifiers also cheaper than the ultra-linear amplifier. The contrast of classical array design with which uses few antennas fed from high-power amplifiers is significant. Several expensive and bulk items such as large coax cable can be eliminated altogether. The typical coaxial cable used to tower-mounted base station today are more than 4 cm in diameter. It's really, it's okay. The third potential is the massive MIMO enable a significant reduction of latency on the air interface. The performance of wireless communication system is normally limited by fading. Fading can render the received signal strength very small at certain times. This happens when the signal sent from a base station travels through multiple paths before it reaches the terminal, and the wave resulting from these multiple paths interfere destructively. It is this fading that makes it hard to build low latency wireless links. If the terminal is trapped in a fading dip, it has to wait until the propagation channel has sufficient change until any data can be received. Massive MIMO relies on the law of large numbers and the beamforming in order to avoid fading dips, so fading no longer limits latency. Okay, the fourth potential is massive MIMO simplifies the multiple access layer. Due to the law of large number, the channel hardens so that frequency domain scattering no longer pays off. With OFDM, each subcarrier in massive MIMO system will have substantial substantially the same channel gain. Okay, sorry, just I lost myself. Okay, substantially the same channel gain. Each terminal can be given the whole bandwidth, which renders most of the physical layer control the signaling redundant. Okay, sorry. The file massive MIMO increasing the file potential is massive MIMO increase the robustness gain both unintended man-made interference and intentional jamming. Intentional jamming of ceiling wireless system is a growing concern and serious cybersecurity threats that seem to be little known to the public. Simple jammer can be bought off the internet for a few $100, and the equipment that used to be military grade can be put together using off-the-shelf software radio-based platform for a few $1,000. And last, the strong link reception performance and interference rejection capability. For the graph, we can find the link reception performance will be enhanced with the antenna number increase, and the interference rejection capability can be enhanced also. Okay. Just now we see the potentials. So now let's discuss the technologies. Actually, it uses a lot of technologies, but today we only discuss 3 of them. First is the channel estimation. Accurate CSI as the transmitter or receiver is required for uplink detection and the downlink pre-coding. Hence, accurate channel estimation is of great importance. Meanwhile, channel estimation is challenging in wireless system due to the inherent and highly dynamic feature of the radio channel. The graph on the left is the MIMO broadcast channel based on user scheduling and the pre-coding, which use the CSI acquired by channel estimation. Okay, there are several channel estimation technologies, including the blunt, semi-blunt, and pilot-based channel estimation. Okay. The other technology is the antenna array design. In the massive antenna array system, the area of antenna array will increase rapidly with the number of antenna increase. We have more antenna, then we need more space. It's a challenge for seating of base station and the antenna array installation. For example, base station needs to install 100 antennas. The distance between each antenna is half wavelength. The carrier frequency is 2.5 GHz. Then we can get the length of the antenna array is 5.94 meter, which is not acceptable. Yeah, it's too long. So there are some methods to solve this problem. First, increase the frequency of carrier. When carrier frequency increases to 25 GHz, the length of the antenna array will be reduced to 0.594 meter, which becomes acceptable. Actually, for this one, it's millimeter wave. Yeah. Okay. The second method is change the topology structure of antenna array. The antenna array could be designed as different shapes, such as square plane, round plane, or cube. In this case, the antenna array should be designed in a square plane. Then the area of the plane will be 0.3 square meter. It's acceptable. It's worth mentioning the channel characteristics will be changed in different topology structure. In the table, we can see that for the fixed amount of antenna, when the number of horizontal antennas increase, the spectral efficiency will also increase. And the third method is reduce the distance between each antenna. As we know, the correlation between each different antennas will be increased with the distance reduced, which will affect the system performance. So it cannot be implemented now, but maybe in the future it can be. When we find some new material, it's possible. And third technology is the downlink encoding. On the MIMO downlink, the best performance will be achieved in an interference-free system without any inter-user interference. For the practical system, we can adopt the precoding as transmitter to mitigate the inter-user interference and reduce the burden of the receiver by signal processing. For the downlink precoding, we have a lot of different methods, such as the nonlinear method. We have the THP and the VP. They are the important technology which can well approximate to the capacity limited in a multi-antenna broadcast channel. And for the linear method, we have MF and ZF. It mentioned that in some investigation, MF is optimal when the baseband antenna close to infinity, but with finite transmit antenna, MF needs at least 2 order of magnitude more base station antennas than 014 ZF to gain the same capacity. Just now we discussed the key technologies, but it also has some limiting factor and the challenges, such as the capacity analysis in practical system. And capacity analysis in practical system, so far the capacity analysis focus on the asymptotic capacity for idle system with an infinite number of antennas. However, in a practical system, the number of antennas cannot grow without the limit. The research on capacity bound of idle situation has little significance for the practical application. Therefore, we should further study the capacity in practical system with a finite number of antennas and more realistic assumptions. And we also have limitations for payload, contamination, internal power consumption, scheduling scheme for much more user pairing, massive MIMO system with TDD model. But I think we don't have enough time to discuss about this. For this, all of this we will discuss for. We can find all the challenges, all the limiting factors on the internet. Although actually for massive MIMO system is a new technology. It's not perfect. It has a lot of limiting, but actually this is the best method, best technology for the future 4G, the 5th generation communication technology. Okay. That's all. Thank you.